Hi. Every change in space are transferred through waves, and waves are essential to understand the physics. Today, we will talk about sound and the physics behind sound. A wave is a disturbance or oscillation that propagates through space-time that transfers energy. There are different types of phase, such as transverse phase, when a wave propagates through a medium vertically to the energy transfer. Longitudinal waves, when a wave propagates through a medium parallel to the energy transfer. Sound is also a longitudinal wave, which we will cover more throughout this video. Electromagnetic waves, mechanical waves, sound is also a mechanical wave, gravitational waves, and surface waves. Wave properties. Waves go through a displacement in a period of time, so it's important to know the related terms to understand their motion. The most important terms are amplitude, period, frequency, and wavelength. The maximum positive displacement of a wave is called crest, and the maximum negative displacement of a wave is called trough. We learned that sound is a longitudinal and a mechanical wave, so let's understand its mechanics. Sound is a wave that is created by vibrating objects and propagated through a medium from one place to another. Longitudinal waves movement is the parallel and same to the movement of the medium. It is important to know that longitudinal waves do not transfer mass. We should also know, since sound is also a mechanical wave, there should be a medium to propagate the disturbance. This medium is usually air. When we speak through the sound wave, one particle starts to move and interacts with another particle, then the other particle interacts with another particle, and this goes on and on. It can be explained with coils. A region of increased pressure is called compression. A region of decreased pressure is called rarefaction. To visualize this, a string can be given as an example. As the string starts to move forth, it begins to push the air molecules, thus causing them to be compressed because of the small space. When spring moves backwards, or the reverse direction, some space opens up and allows particles to move more freely. Normally, the wavelength is calculated through from a wave's crest to the other crest. Since longitudinal waves do not contain any crests nor troughs, the wavelength is calculated from one compression to the other adjacent compression. Since sound waves consist high and low pressures, it is sometimes called pressure waves. The peak point of the wave is a high pressure, and the low point is a low pressure. Sound waves have repeating patterns, and pressure versus time plot will appear in a sine curve. This shouldn't be mixed with transverse waves. As we said earlier, frequency was how often the particles in the air vibrate when a wave passes through the medium. This means when particles move more often, there is a high frequency, and when they move more slowly, there's a low frequency. However, frequency is not only determined by back and forth vibrational motion, it is also determined by period. A pressure versus time plot with small period means that there is a high frequency, and the pressure versus time plot with a large period means there is a low frequency. Do not forget that frequency is reciprocal of period. The amount of energy that is transferred to the medium is dependent upon the amplitude of the vibrations of a guitar string. When we vibrate the string with more effort, it means that there will occur a higher energy that needs to be transferred, and also we need more work to transfer a bigger energy. The amount of energy that is being transferred through the medium means the intensity of a wave. If the amplitude of the vibrations is bigger, it means there is a bigger amount of energy being transported. This can be calculated through energy over time over area, and since energy over time is equivalent to power, it is basically power over area. The unit for intensity is 1 watts per meter square. When we go further from the sound source, the intensity lowers. This relation is called inverse square relationship. If the distance is doubled, then the intensity decreases by a factor of 4, like in this situation, A and C. If the distance is quadrupled, then the intensity decreases by a factor of 60. This is why it is called inverse square relationship. The sensation of a frequency is commonly referred to as the pitch of a sound. As we said, humans can detect and process many sounds, but there are also sounds that humans can hear. A person can hear sounds between 20 Hz to 20,000 Hz. Dogs, on the other hand, can hear sounds between 50 Hz to 45,000 Hz. There are also other examples of animals that can hear much higher sounds. Any lower frequency that can't be heard by humans are called infrasound. Any higher frequency that can't be heard by humans are called ultrasound. If we understood the sound intensity, we can move on to the related terms with sound intensity. We know that humans can detect a wide range of frequencies. They can also detect the very faint sounds, so the low intense sounds, down to 1 times 10 to the power of negative 12 watts per meter square, which means that it corresponds to a sound that will displace a particle of air by a mere 1/1000th of a centimeter. This border is called threshold of hearing, TOH. Because of the reason that humans can hear a wide range of intensities, scientists measure the intensity with a scale base of powers of 10. This scale is called the decibel scale. The threshold of hearing is 0 decibel, and 10 times more intense sound will be 10 decibels. This goes on like that. The limit for human ear is 160 decibels. We can understand that this is 10 to the power 16 times more intense than the THO. Even though this doesn't fully correspond to loudness, it can be said like that. With greater amplitude, the loudness will also increase. The thing is, people can detect sounds easier between 1000 Hz and 5000 Hz. That is why it can be understood louder. Other than that, it shouldn't be mixed with frequency or pitch.
Also, there are more things about sound and sound waves. If you want to know more about them, do not forget to watch part 2.